Hello friends, welcome to my YouTube channel Aviator Updates. If you don't know me, I'm Rakesh Negi and I'm an aviation enthusiast. Today we are going to discuss about vibrating contact regulator principle. Okay, we know well in aircraft we use generators. Prior to the modern day generators, in the olden days in small aircraft we used to have small generators of DC type which used to produce 28 volt DC. So in those generators, how was the voltage regulation done? So voltage regulation in those DC generators was done using different type of regulators. Okay, so one of them is vibrating contact regulator. Okay, so I'll be discussing about its principle. How does it work? Okay, and how does it regulate the voltage output of the generator? Okay, so let's start. So before I start, note one point that the type of generator which I am using to explain the system is shunt type DC generator or shunt DC generator. Okay friends, so let's start. Suppose this is the shunt generator. We know well in DC system there is a positive end and a negative end. We'll talk about AC later in another session. So this side is positive, this side is negative, that is the ground. Okay, so this is the ground terminal. Okay friends, so this generator will develop the voltage and that voltage will be given at its output terminal. Suppose this is the terminal through which we collect the output voltage and give it to the system, the distribution system. So I'll just write here to distribution system or consumers, whatever use the output voltage of the generator. So this is the positive end and negative end is the ground terminal. Okay, the aircraft structure or the aircraft body. Now in this, how is the regulator connected? Okay, in the vibrating contact regulator there is a voltage regulator and a current regulator. So suppose this is the core of voltage regulator. I'll just write here voltage regulator. And suppose this is the core of current regulator. Current regulator. Okay friends, so there is a voltage regulator core and current regulator core. So in this, what do we have? How is the connection done? So we know well, since this is the core, there will be winding also. So in the current regulator, how is the winding connected? Remember that in current regulator, the windings will be few turns of thick copper wire. Okay. So from the generator output, I'll connect the output with this core. So this is the winding which is connected to the core. Suppose I'm using this blacking to represent few turns of thick copper wire in this core. Okay friends, so what have I drawn here? This is the current regulator and its winding, that is few turns of thick copper wire. Next, we should note that the coil of this current regulator is connected in series with this voltage regulator's coil. Okay, so let me draw voltage regulator's coil first. In vibrating contact regulator, for the voltage regulator we have two types of coil. One is many turns of thin copper wire, that is called as the shunt winding. So I'm using blue ink to represent many turns of thin copper wire. Okay. So suppose this is the shunt winding. Okay friends, so this shunt winding is connected in series with the current regulator's winding. Okay, that means this winding of the current regulator, which is in black, is connected with the shunt winding of the voltage regulator. That means current regulator and voltage regulator, how are they connected? They are connected by their coils, and the coils are connected in series. As you can see here, this coil is connected in series with the shunt winding of the voltage regulator. Okay friends, so I'll just write here shunt, S-H-U-N-T, shunt winding. Okay friends, now as I have told you, there are two types of coil in the voltage regulator. One I have already told you and shown it here. The other type of coil which is there in the voltage regulator is of what type? It is having few turns of thick copper wire. So I'll draw here few turns of thick copper wire. 1, 2. Okay, so this is the voltage regulator. This is its series winding. This is its series winding. Hence the conclusion, in voltage regulator there are two types of windings. One is shunt winding and one is series winding. How are they connected? Shunt winding is connected in series with the current regulator's winding. Okay, this few turns of thick copper wire is connected with the many turns of thin copper wire. So this is how current regulator and voltage regulator windings are connected. So from here the supply will come, from here the current is coming like this. When the generator will be running, current will be coming, and this is connected with the ground terminal, right? Next, what about this other winding? How is it connected? This winding, series winding, is connected to a contactor, which I'll draw over here. So this is a contactor called as the armature. Okay, what is it called? Armature. So this one is the armature. Okay friends, this one. So this is the armature which can move. So this is the movable end of armature. Okay, and fixed end of armature is this one. This is also made of metallic contact. And how is it connected? This end, I'll just take the connection from here. This end is connected here. Okay friends, I'll just erase this, and the other end is connected to the other contactor like this, to the other armature. So this is another armature. Okay, this armature, by means of spring tension, it is connected to a mounting. So this is a mounting, and this is a spring to which armature is connected. Here also there is a spring on this side. Okay, the tension of this spring, how much it will be friends? The tension of this spring is adjusted according to a predetermined value of the output voltage of generator. Okay, so note one point. The tension of the spring is adjusted such that it corresponds to a certain predetermined value output voltage of the generator. So this is a mounting on which spring is there and armature is connected. So this armature is movable, and the other contact point to which it is connected is a fixed contact, and this armature is a movable contact. Same way this side. This is a fixed contact and this is a movable contact. Okay, so right now the armature is closed because of the spring force pulling it. Okay, so this side also the spring force has pulled the armature down, hence both the contacts are joined. And this end is connected to the again output terminal of the generator. This contact is in touch with this contact, because of which the current will flow like this via the series field winding. It will go via to this contact, and via this contact it will be given, or it will be connected to the generator's field winding. So this is the generator armature, and suppose this is the field winding of the generator. Okay friends, so this is the field winding of the generator. It is connected with like this. One more thing friends, this connection is also connected to another path through which current can flow, but here the current will flow by means of a resistor, and then it will be connected to this connection like this. Okay, I mean to say the field winding of this generator can get current from this path or this path, depends on the condition when generator is running. Okay, I'll explain about that. So right now on this, what I have shown you the generator, its field winding. Okay, this field winding is of shunt field winding, so do not get confused with the shunt field winding of voltage regulator and shunt field winding of the generator. This field winding is within the generator. Okay, this is a part of the generator field winding, and this is the armature. So this is what I have shown. Next, what I have shown is the voltage regulator. Next, I have shown a current regulator where we have few turns of thick copper wire. Okay, next we do have some contacts which can open and close, which are called as a movable contacts. Okay, it is based on these contacts movement that the name of this regulator is kept. Vibrating contact regulator means these contacts can vibrate. Okay, how do they vibrate? This armature can open close. Okay, likewise this side armature also can open and close. How does it open and how does it close? We'll discuss when I'll be explaining the principle. Okay, next, what else we have discussed? We have discussed that the current regulator's winding is connected in series with the shunt winding of the voltage regulator. Right, I repeat again, the winding of current regulator is connected in series with the shunt winding of voltage regulator. I hope this point is clear. Next thing, what about the series winding of voltage regulator? The series winding is connected in series. As you can see here, this winding is going and it is connected by this path to the winding of the generator. That means the series winding is connected in series with the winding of the generator. Hence the name series winding. And why is this called shunt winding? Because this shunt is connected in parallel. Note one point, shunt is always connected in parallel and series is also always connected in series. Hence the name series winding and shunt winding. So this shunt winding, if you see, its positive end is connected with the positive and negative end is connected with the ground. Hence this shunt winding is connected in parallel with the generator but connected in series with this current regulator winding. Okay, as you can see here. Okay, now what we'll do is we'll learn the working principle of this regulator. Case 1. So suppose the generator has started and it is running. Okay, so when the generator is running, we know well it produces the output voltage here at its terminal. When it is producing the output voltage, what happens at that point of time is this contact and this contact, both of them, they are closed. That means the armature and this contact are closed. How are they closed? Because of the spring tension. The spring is pulling the armature towards it. That's why this contact, these two, the armature and the contact, both of them are closed. So likewise on this side, because of the spring tension, this armature and contact both are closed, because of which the output is taken, it flows in this direction via this contact. It will flow via the series winding. It is flowing like this, and it is given to the field winding of the generator, and that's what we want. So the excitation current of this field winding is increasing. How? From the output, via this connection, the supply is given to the winding. Hence the excitation current is increasing. As the excitation current increases, magnetic field will be more here, more flux will be cut. Hence generator will develop more voltage, and that voltage will be increasing. So now let's discuss case 2, in which the voltage is increasing. Okay, I mean to say the output voltage of the generator is increasing. In that case, voltage regulator plays the main role. So what happens? If the voltage is increasing from this point, see, the current is taken, it is going via this coil connected, which is connected in series with the shunt. As the current is flowing through this winding, that current will produce a magnetic field around it. Current is coming in this winding from here. Via this, it is coming and it is flowing in this series winding. Hence both of these windings are having current flow. Okay, the shunt is having from here via this current regulator, and the series winding is having from this path, from this armature, and then this. This is how the series winding is having the current flow. So both the windings are having current flow, because of which electromagnetic force is created. That electromagnetic force, which is developed by the shunt winding and series winding, will pull the armature and the armature will open. Suppose this is how the armature opens. So armature has opened. This fixed contact will remain here, movable contact will open. So there is an open connection now. Okay. So why did it open? It is because the electromagnetic force produced by the voltage regulator coil and its core is stronger than the spring force. Hence it has opened. Once it has opened, the series winding current was connected like this. It was going to the winding of the generator. So this series current cannot go into the generator. So what will happen? This winding current will collapse. It will not go to the field. If it does not go to the field, what will happen? The voltage will, output of the generator will start reducing. So this path is useless now because current is not going to the field winding of generator here. This path has become useless as this path is not giving current to the winding of the generator. Hence, in this case, now the current will follow this path. Okay. In normal condition, current was not following this path. In normal case, current used to follow this path when both the armature are closed. Why? Because this is a high resistance circuit. Current always follows low resistance path. So in normal conditions, current was following this path, but now when the armature is opened, current will follow this path. So current will come from here via this path, it will go via a resistor. Okay, so we are discussing the case in which the voltage is high. So voltage is high, current is flowing from here, and now the current will decrease. When the current decreases, a decreased current will be given to the field winding of the generator. So when the generator output is higher here, the current which is given to the field winding is less because of this resistance. So because of this resistance, since the current given to the winding is less, the excitation is less. As the excitation has become less now, the voltage output will automatically reduce and it will come back to the normal level. So once it comes to the normal level, now let's discuss case 3. What will happen is this contactor will close again. How? The voltage output has been reduced. Okay, that is case 3. So here, from here the current will go, the electromagnetic force will become less. So as the electromagnetic force become less here, the spring force will dominate. The spring force will pull back the armature and close it back. And close it back like this. So now again this path has been closed. So again the current will follow this path as like in the normal case. And hence again the current will increase to the field winding of generator. Excitation current will become more, and again the same cycle will continue. So this contact, it used to open and close continuously, okay, depending on the load, how much load has been connected. Okay, but on a general load, this contact opening and closing happens around 50 to 200 times per second. That means it used to vibrate, hence the name vibrating contact regulator. Okay, so this is all about the voltage regulator. Okay, so what did the voltage regulator do? The voltage regulator, when the voltage was going higher, okay, from here the current was flowing, its shunt winding and series winding, they produced a magnetic field which creates a strong magnetic field. That strong magnetic field used to pull up this armature, hence opening this contact. Fixed and movable contact will open. Why? Because the electromagnetic force is dominating here and not the spring tension force. Hence this contact has opened. Once this opens, the current which was going to the field winding of the generator will be cut off from this path, and this path will be followed, but this path has a resistance. So this resistance used to decrease the higher current which is coming from here. That decreased current is given to the winding of the generator, and this is how the output voltage will decrease. Okay, so that is all about the voltage regulation. Next, let's discuss about the current regulator. So current regulator is basically to control the output current. Okay, how does it control? When the generator is running, suppose the output current is higher. Okay, that time we know when the output is being collected from here, it is going like this and going in this coil. This coil is having few turns of thick copper wire. So whenever there are few turns and the wire is thick, that means the resistance will be low. Yes, so resistance will be less. So when resistance is less, current flow is more. So that is what happening in this coil. So current flow through this coil will be more. So when the current flow will be more in this coil, the magnetic field which will be produced by this will be more, and hence it will develop a stronger electromagnetic force which will pull out, or which will pull this armature upwards, and hence these two contacts will open. Once it opens, what will happen is, see, this is how it will open. So contact will open. Once the contact has opened, see, the current cannot follow this path now. So whatever current was coming from here and given to the field winding of generator, the current cannot follow this path. See, that means the current in the field winding will collapse. But something should always be given to the field winding. So now that some current, where is this winding getting from? Okay, it is getting from this path. Since this path has opened, since this path cannot give the current to the field winding of generator, hence this field winding will accept current from this path. Current will follow this path, but here again there is a resistor. The resistor will reduce this current, and that reduced current will be given to the field winding of the generator. So when the field winding of the generator gets lesser current, we know well friends, the magnetic field it will produce will be less, and flux which will be cut will be less, and when flux cut is less, the output also will be less. And this is how the output current is controlled by the current regulator. Hence the purpose of current regulator is to limit the output current. Okay friends, so let me summarize the topic friends. In this topic what we have learned? We have learned that the generator which we use in the aircraft, its output voltage and current both can be controlled by using a voltage regulator and a current regulator. The contacts which are used in this current regulator and voltage regulator, the contacts are of movable type, okay, which used to vibrate. Here also it used to vibrate. For the voltage regulator also it used to vibrate. For current regulator also it used to vibrate at almost the same frequency as like for the voltage regulator, which I have said it's from 50 to 200 times per second. So that is about these regulators. So this regulator is used in small aircraft having DC generators. It is not much advanced. Why? It's because there are some problem in this type of regulator. Okay, what is the problem? I'll tell you friends. The problem is the contactors, the fixed contact and the movable contact. As we know, they are vibrating at certain frequencies around 50 to 200 times, because of which their life becomes less. Okay, they will burn and sparking will happen. Hence, this type of regulator is not used in the modern commercial jets. It is only used in the basic small DC aircraft. Okay, so in small DC aircraft, also you should note that advanced voltage regulators are also there, which I'll explain in some other session. I'll come up again with a new topic in my next session. Till then, enjoy learning this, and if there is any doubt, do comment below, and thank you.